Hello and welcome to Learning Economics. This is our third video in the series of data analysis and econometrics using R. In the first two videos, we have covered RStudio interface, why R is an important software to learn, and we have also learned how to create different variables using different basic functions through RStudio. In this video, we shall learn how to import data from external files such as Excel file or CSV file to R. Further, we shall learn about data frames, data structure, and some basic data analysis such as getting summary statistics or descriptive statistics. So let's come to the interface of RStudio and learn these things by doing it itself. Dear viewers and listeners, let's first see how we can import CSV file in our studio. To import a CSV file in the R studio, we shall use a function read.csv followed by the path of that file. However, before doing that, we should first think about the name of this data frame. I shall explain the term data frame to you later. Let's say I want to name it as WHO and all in capital. This is important. Whether you name it in small letters or capital letters or a mix of two, that is important because R is case sensitive. So I chose the name of the data frame as WHO in capital. I shall be using function read.csv followed by the path of that file. For example, let's do it on R. I have a file named WHO in small letters. I want to import it in R. That's a CSV file. So I will be writing first the name of the data frame, which as I told, I'm going to give a name WHO as capital. Then I shall follow this symbol, which is less than and minus sign. And then I shall use the function read.csv followed by the path of that file. I have stored it in my local disk D in a folder videos R, and there this is that file. So I have copied that. I'm pressing enter and it's saying that it's unable to recognize this character. Okay, what should I do? Should I write it by this? Let me try it. And yes, here that file has been imported. So we have to use slash for this. As you can see in this global environment pane, there is a data file with the name WHO in capital, and if you look at its description, it says 194 observation of 13 variables. This is there in the data. We can use it as per our requirement now. Now, before I tell you how to import the Excel file, let me tell you about the data frame. Data frame is actually a name given to a table or an array in which there are columns and rows. Variables are represented in columns, whereas the observations under each variable is given in the rows. So the whole structure like that is called as data frame. You can think about data frame such as an Excel file that you have downloaded, and once you click it, you have multiple variables in the columns, and then their information is given below their name in the rows. So that whole file is a data frame. And R does not import individual variables, it imports the whole data file and calls it as a data frame. This actually enables R and thus the users to use multiple data sets at the same time and work simultaneously on all of those data sets. Let me just give you a brief overview of this. We can get its overview by clicking on it, and it is loaded there. You can see the countries: Afghanistan, Albania, Algeria, and other countries. Then there are region. There is a variable of population, under 15, over 60, fertility rate, life expectancy, child mortality. These are all different variables, and below them there is the information. If the information is missing under any variable, it appears as NA. Okay. Zero is an information. So if you have some missing information, never replace it with zero. One, leave it blank. Once you will import it into RStudio, it will label it as NA, not available. If you labeled it as zero, it will record it as an observation whose value is zero. So this is something important. We will look at the data structure in detail later. Now let's import another file, which is an Excel file with XLX as its extension. So how we can do that? We can do that in two ways. One, we can use a similar function like read.xlxs, which is the extension name. If that function is working, very fine, but if that function doesn't work, that means you need to install that package. A package in R is actually, you can say, a small software or a small coded file which once stored enables R to perform that function. Packages usually come along with the data set to practice and along with the help files. So let me try to first get Excel file by using a similar command. If that didn't work, I shall load the package. However, if that worked now, we shall load packages and learn about using different packages in later stage of our course. So now I want to import an Excel file, XLSX extension, which is stored as practice. The name of the file is practice. So I will go to the previous command. How can I go there? I can press arrow upward. I went to this, so I will change the name of that data structure. I named it PRAC, and then I just change this read.csv to read.xlsx, and the file name which I am trying to import now is practice, practice.xlsx. Just let me check if the name is correct. So the name is practice XLSX. Yes, everything fine. So let's try to import it. And again, it says that it could not find a function namely this. So let's install that package. We shall use install.packages, and then we shall write the name of the package, which is read.xlsx. Now it will look for this package in different libraries, and once this package is available, it will load that package. So let's wait. No, the message is that this package is not available for this version of R. Earlier I had an older version of R where this package was available, so I used that. Once the author will update it for the current version, it will become available to us in the current version as well. So then what can we do? There is no issue. We can go to the file and we can use this import data set, and we can call, say, it import from Excel. Here we need to give the file path. I shall use the browse, and I have data in my T, and in my videos are file, and here I have the practice data, so I selected it. Here I can give the name, so I would prefer an PRSC. Sheet, you can say the first sheet, second sheet, third sheet. You can, here you can give it that first row has names or not, and then we can also configure it to how many rows we need to import. So we can import all that, or we can fix the range from here as well. So from anything here, we will just click on imports, and yes, it uses read underscore xlx command, and the data is imported. It has also opened this data for us. This has variables such as CS, size, education, edu, inc, most probably income. You can see that a new data frame PRSE is added over here. It has 16 observation of 4 variables. So this is that data set. Fine. You can also load the CSV file from here as well. You can go to the files, import data set, and then import text. From the text, it will import CSV data file. It can import SPSS, source data, and many other formats files. There are different packages available that help us import the data from PDF as well. So this was all about importing data into R. Now let's look at the data structure, try to understand it, and then we shall move to the summary statistics. Now let's see the structure of both of these data sets to learn more about the kind of the variable, the observations, and other things in the data. So first, I am interested in knowing the structure of WHO. Since there are multiple data frames in the global environment now, as you can see, PRSE is one data frame and WHO is second data frame. So even if we have only one data frame or we have multiple data frame, while working in R, we always have to mention the data frame. We should always be giving the reference of the data frame on which we are working. So just to get the structure of the data, we shall use str. This is for the structure, and I write here WHO. So if I write WHO in small, I will not recognize it. So it says that this object has not been found. It's because R is case sensitive, and I have given this name in capital. So I'm just now I am writing it in capital, and yes, you can see it says that this data frame has 194 observations under 13 variables. First variable is country. This is character variable. That means there are alphabetic or symbolic uh, entries into that, and it has shown some of those entries. Then region, it is again a character variable. It again has some alphabetic entries in it. And then population, it is integer. So integer variable, it has some values, and values are in whole numbers. And then under 15, it is a numeric variable. It has values in decimal points as well. So over 60, it's again this, then numeric, and then you can see life expectancy is integral variable. So it reads integer if there are whole numbers, and if there are some decimal points, it reads them as numeric variable. And if there are some missing entries like n, it represents them as NA, but all other entries are in decimal points or whole number or mix of the two, so it is reading it as NUM, numeric variable. So just looking at the data structures gives us some very useful information about the data. So always make it your practice to first view the data structure and then start analyzing the data. Now, if I am to use this, if I am to see the data structure of our other data frame, that is PRSC, I will write str hit enter, and now you can see it says that it is a table. It's a well-structured table because it doesn't have any missing value, so it's calling it as a table. 16 by 4 are its dimensions. It has a variable CS, it's numeric variable. It has a variable size, it's again numeric variable. Education and income, all the variables are numeric variable, and it is showing first few entries of those variables. It is always very important to first understand the data set on which you are working. Once you get yourself fully familiar, you must know what is meant by CS, what is meant by size, what is meant by EDU, what is meant by INC, how these numbers were collected, how this, what this data represents, or what this variable specifically represents. And once you understand all of that, then start analyzing the data, because it's very important to first know the nature of the variables and what these variables are representing, how the data of these variables was collected. Now, let's see some of the basic statistics of one of these data or both of these data. So let me show you. We give a command summary, and then of course summary followed by the name of the data frame. It's PRC. Oh, sorry, I misspelled it. SUMMARY, summary, and then PRC. So it's giving me the variable CS has minimum value as 1, first quartile value, that is Q1. It's the value that cuts data at 25%. That is 25th percent of the data is one side and remaining 75% is on the other side. This is meant by the quartile. So it is appearing at 2.75 median. Median is the middle value of the data that cuts data from the midpoint, that is 50% of the value is below it and 50% of the values are above it. So that median occurs at 4.50. Mean also occurs at 4.50. Third quartile, it cuts data at 75th percent. So 75% of data is on the one side and 25% is on the other. This is at 6.5, and the maximum value of the data is 8. Similarly, you can see all these statistics for size, education, income, that means for all the variables. Now, if I want to see the summary of my other data frame, which is WHO, I will use the same command summary, but now I shall ask it for WHO. Once I click it, because this data has many values, so it will give it summaries as first variable is country, its length is 194, that is total number of observation under this, and because it's a character variable, so you cannot find the mean or median or etc. Okay, so then region, it is also a character variable. Its length is 194. Population, this is a numeric variable. So for the numeric or integral variables, it will give you the similar information. Minimum value Q1, that is first quartile. Median, that is the 50th percent of the data. Mean, that is the middle value of the data. Third quartile, and maximum. You can see this for all the variables under 15, over 60, fertility rate, life expectancy, child mortality, and all of other variables that are there in this data set. So this summary statistics gives you some very good information about the data. Of course, we can get other statistics like if we want to see for example 20th percentile, that is P20, which divides data by 20%, we can also get that. We sometimes need to know the standard deviation of the data or the spread in the data, means variance. We can get all those of the statistics, which I will cover in the lectures to come. So here is that brief statistical summary of the data, which gives you some useful information about the underlying variables in the specific data frame. So with this, sometimes we need to create a subset from the data. That is from, for example, we have the WHO data. There are various regions. If I am just working on African region, then of course I will be more interested in African regions data, not in the whole data. So I can decompose or I can extract the African regions data from this huge data frame, and that will become a subset of that data. How we can do that? Let me show you. So like first you will need to think what name should you give to this new data frame. Let's say I give it a name WHO underscore AFR, Africa. Now I'm using the small letters, and I prefer to use small letters. Again, the symbol, and what I need to do, I need to make a subset of WHO data. So I will use the function subset, and now I need to refer the data frame in which I am interested. I am interested in WHO. And now I need to specify how to create that subset. So I would write the variable of my interest, that is region, REGION, as I am and equal to which value should I get? I am interested in only Africa, AFRICA. And since it is a character variable, so I must specify it in inverted commas. Had it been the numeric variable, for example, if I am interested in all those values where under 15 value is less than 50, then I would have written subset WHO, the data frame, then comma, in the place of region I must have written under 15, and then I would have written is greater than 50 or less than 50, or let's say equal to or greater than 10, whatever my criteria is to make the subset. And in that case, because that is a numeric variable, so I do not need to give it in inverted commas. This we covered in the a previous lecture as well, in which we learned how to make variables and how to use different functions. So subset is also another function. So let's use it. Now it has created, as you can see, it has created this subset Africa. It has 194 observations of 13 variables. Why? Region will be discarded. It should have only African variable. Let me try it again, or let me have a look at my command where I made the mistake. Subset WHO equal to AFRICA. Let me see the name AFRICA. Yes, it is exactly right. Oh, sorry. There is a small mistake, and this is a very common mistake that I make. Just first let me correct it, and then I'll tell you what's the mistake. Here, I would need to use equal to sign twice. When we use equal to sign once and when we use it twice, we use this sign once when we need to refer equal to some external value. For example, I say 10. Now I am not using this value 10 from the data set. I am giving it from external source. But if I am using that value from within the data frame or data set that I have, then I shall need to use double equal to. So it will search this value. When it will match with Africa, it will extract that. And you do not need to change the name of data frame. It will replace the given data. So now you can see the given data frame has been replaced. It has 46 observations of 13 variables. If we view this, you can see all the region is only Africa. In this way, you can create any subset as per your requirement and work on it. So that is all for this video. In the next video, we shall start exploring the data using various charts, diagrams, scatter plots and other, and look at various statistical characteristics of the data to get more into the data analysis. So slowly we will now dive deep into the data analysis. Please subscribe to this channel, share these videos if you find it useful with your fellows. Give your feedback in the comment section below this video. Thank you and goodbye.